How do we interpret what's meant by the recurrence interval? We've been a little bit simplistic about it so far. We've talked about how the recurrence interval is the average time between successive events. But in fact, it's important to keep in mind that, and this is a mistake that people often make when they're interpreting what recurrence interval means, it's not the exact time between successive events. Let's look at an example. Here are the times in the left-hand column at which major earthquakes occurred on an imaginary fault. On the right-hand column is the time between the successive events. So, for example, the oldest event that we had was 985 AD. The next event was 1069. The next event was 1279. So we can see that one interval is 210 years, another interval is 46 years, the next interval is 312 years, the next interval is 218 years. Overall, you average those numbers, you get a recurrence interval of about 170 years. Now, what does that mean? Well, a better way of looking at that is to translate that into a number called the annual probability. And what that means is how likely is an earthquake, a large earthquake, going to happen in a given year. And simply put, the annual probability is 1 over the recurrence interval. So if you divide 170 years, or you divide 1 by 170 years, you get an annual probability of 0.6%. That means in a given year, you have a 0.6% chance of having an earthquake of that size. So think about what's meant by a 0.6% chance. It's not quite 1 out of 100, a little less than 1 out of 100 chance. But it means is you have a little bit less than a 1 out of 100 chance of an earthquake of that size happening in a given year. I'll make one addition to this discussion of recurrence interval, and that is that because earthquakes happen in general by the stick-slip phenomenon that we've talked about, the more time that has passed, indeed, the more likely it is that an earthquake is going to occur. So if you have a recurrence interval of, say, 170 years, and it's like 10 years after an earthquake's happened, yeah, you've probably got an annual probability that's describable, maybe an annual probability of 0.6%. But realistically, it's probably not too likely that that earthquake's going to happen. However, if 170 years or 200 years or 250 years has passed, you're probably getting in the range where earthquakes are getting more and more likely. So because of the concept of stick-slip, we can say that earthquakes probably are more likely the more time that has passed since the last event on that fault. Now, with this in mind, we can actually go one step further and imagine that on a given long fault, we can perhaps predict that certain parts of that fault are going to be more likely to slip than other parts of that fault. And what I'm showing here is a map of the Anatolian Fault in northern Turkey. The graph shows areas that have been affected by earthquakes at different times. In some cases, a larger length of the fault was affected. In some cases, a smaller length of the fault was affected. But what you can see is there's been a gradual unzipping of the fault from the east to the west over time. And so some geologists have suggested that perhaps the next big event is going to be towards the west end of this Anatolian Fault. To finish off our discussion of recurrence interval, we can make an analogy between studying recurrence interval of earthquakes and chaos theory. Look at this shell. There's a definite pattern to it, but you can't predict the shape of any specific cusp on the shell by looking at its neighbor. And it's the same with earthquakes. Overall, there's a repeatability to earthquake activity on a given fault, but we can't give precise constraints on exactly when and where an earthquake is going to occur.